All right, team. So we're going to continue here in thinking about proportions. So in this case, if we want to solve a proportion, we are given some data. And the way that our data is given to us in this scenario is through this table. So the values in the table represent a relationship that is proportional. And that's key in sort of being able to solve for our missing or mystery variable here. So we can say, all right, well, if we know these are proportional in terms of the blue paint to the red paint or whatever, we know that we have a 6 to 20 6-ounce of the blue, right, in paint 1 versus a 20-ounce of the blue in paint 2, equivalent, which is equivalent to a 15-ounce in the red paint 1 to a mystery of the paint 2, right, of the red ounces. So I'm just taking this data from the table and I'm making it, I'm kind of sort of transforming it, if you will, into a look that's familiar. So we've got our ounces of paint 1 to paint 2 for both of these. And now we can solve. We know that it's proportional, so we can solve for our mystery, right? We can solve for x. And we want to do that if we think back or look back at your notes, right? You're going to see that what we want to do next is use our cross products, our cross multiplying, right, to set up our equation. So we'll say, all right, so 6x or 6 times x is equivalent to 15 times 20 or 20 times 15, whichever way you want to write it. Okay, so as we then look at our notes, we know that the next step, right, is essentially to combine these like terms here. So we have our 6x and then we want to do 15 times 20, which gets us 300. So we can say, all right, this is no longer called 15 times 20. It's now called 300. So we have 6x is equivalent to 300, but we want to know how much is 1x, right? And x is like, ugh, 6, please get away from me already. They're connected by multiplication, so 6 is like, sure, I'm just going to do the opposite, right? Get out of here. So I'm going to divide. So if we do that, we essentially end up with 1x. Legal to do so long as we do the same thing to the other side. So 300 divided by 6 will end up getting us 50. So then we can go back, we can put our 50 in here, but we can go back to our original physical setup, our original problem, and we can say, all right, X, you're no longer a mystery. You are now called a 50. Dun, 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 dun. So let's go ahead and check it. And you can do it one of two ways, right? You can go back and simply do cross products, right? Say 6 times 50. Well, yeah, I know that 6 times 50, it got us that 300, and 20 times 15, well, yeah, also got us that 300, so check, they're equivalent. You could also go the opposite route, and you could think of this like a division problem. 6 divided by 20 gets you 0.3, and 15 divided by 50 gets you 0.3. Either way, they're equivalent. So you have checked and proven that indeed this mystery is no longer a mystery, it's history, and it's now called